Algebra 2, Cram, New York State Algebra 2 Regents, Common Core, Key Facts, Trigonometric Functions, Unit Circle, Question 8, the cosine of theta and sine theta. To order this complete Cram session, inbox me at memedicine@gmail.com for pricing and ordering instructions, and be sure to spread the word to your classmates and colleagues who also need to cram. And they can inbox me as well at memedicine@gmail.com. All right, let's delve into the question. Review question 8. If theta is an angle in standard position and its terminal side passes through the point 1/2 radical 3/2 on a unit circle, as shown here, a possible value of theta is 1, 30 degrees, 2, 60 degrees, 3, 120 degrees, or 4, 150 degrees. I'll give you a moment to think and put your answer together. Definitely press pause. All right, so hopefully by now you've pressed pause and you were able to arrive at an answer. And if you didn't, that's completely fine. Let's try this together. Okay, so if theta is an angle in standard position, and when I say standard position, I mean the vertex is located at the origin, as shown here, and the initial side ray is on the positive x-axis, and the other ray, the terminal side, intersects the unit circle. Okay? All right. So this means that the cosine of theta is equivalent to x, and the sine of theta is equivalent to y. And in this problem, x and y are both positive, so the angle obviously is in quadrant 1, and it's also shown here to be in quadrant 1 as well, okay? And note that the reason why a unit circle has its number is because the radius is equivalent to 1 in all directions. So 1 unit, hence the name unit circle. All right, and the reason why it's in quadrant 1, well, even though it's shown here in quadrant 1, let's just re-emphasize for some clarity, okay? The cosine of any angle theta is basically equivalent to x over r. When I say x, I mean the x coordinate, and when I say r, I mean the measurement of the terminal side ray. And the terminal side ray, or the hypotenuse, will always have a positive measurement because you are considering that numeral, the measurement. A measurement of something that exists can never be negative. But an x-coordinate or a y-coordinate can be negative depending on where you're located in the Cartesian coordinate plane. That's why some cosine and sine values are negative, okay? And likewise, the sine of theta is equivalent to the y-coordinate over r. So in quadrant 1, both the x-coordinate is positive and the y-coordinate is positive. That's how we can locate our angle theta of interest to quadrant 1. Okay? All right. So we're told, let's work with the cosine because I like working with cosine. We're told that the cosine of this angle theta is 1/2. It's a cute number to work with. So if the cosine of theta is equivalent to 1/2, what we would have to do is take the inverse cosine of theta, and whatever we do on the left-hand side of the equation, we also have to do on the right. Therefore, we take the inverse cosine of 1/2. And taking the inverse cosine, well, actually, this should be the inverse cosine of the cosine of theta. So let me just indicate that this is actually, this should be the cosine of theta. Okay, and that basically unravels the theta. It frees up the angle. That's what that should be, okay? And so, yeah, basically, you're going to get theta is equivalent to 60 degrees, okay? And you can also, well, obviously you have to do this on your graphing calculator unless you memorize, I mean, the basic trigonometric functions of highly repetitive angles such as 30, 60 degrees, 90 degrees, 0 degrees, 270, 180, the quadrantal angles. So you have to memorize some of the, again, trigonometric values for common angles, okay? But if you, in case you didn't, you would have been able to solve this inverse cosine equation on your graphing calculator. The graphing calculator series I'm going to refer to is the TI series, okay? So basically, the first thing that you're going to want to do is ensure that you're in degree mode. And you can do this by pressing second mode, and the screen will pop up. Then your cursor is going to be flickering over normal. You hit the down arrow once. It will then be flickering over float. You hit the down arrow once again. And then it's going to be flickering over radians. Well, let's just pretend that degrees isn't highlighted and radians is highlighted rather. What you're going to do is then press the right arrow and it'll be hovering, the cursor that is, hovering over degrees. You don't need to press enter to lock in the degree mode. All you need to do now is press second mode to quit this screen, and then you'll go to the main screen, okay? Where you can then input your inverse cosine function. And so this is what it's going to look like. You're going to take the inverse cosine of 1/2, and in order to do that, basically you're going to press second cosine, and that will bring up the inverse cosine function, which comes preloaded with an open parentheses. Then you're going to hit 1 divided by, the divided by represents the fraction bar, 2, and you're going to close out that parentheses, okay? And then you're going to hit enter for your answer. And when you do that, you're going to get 60, as in 60 degrees, because we're now in degree mode, okay? Therefore, the correct answer choice is going to be answer choice 2, 60 degrees. All right, thank you for tuning in. See you next time.